is give you some idea of how if we don't use the concept of simultaneity, space-time carefully, we can end up with some paradoxes, and then we will discuss how to resolve the paradoxes, and that will it will give us more insight into special theory. So, what I'm going to do is I'm going to discuss the following ones. The first one I will discuss is the rocket. I will list the paradoxes I have in mind. The second one is a rocket and a plane. When I mean by plane, I mean a geometric plane, not an aeroplane plane. A plane. The third is Shastri's paradox. This is by Professor Shastri from IIT Kharagpur. We have got a very nice paradox. We will discuss that. I will discuss this at length. So I will discuss that at length. And then I will discuss the twin paradox. If I still have time, I will discuss how things look like. And some few examples how if you use a different concept of trying to observe things, then what they look like. There is a very nice statement in the paper of Shastri about paradoxes, and I will just write that down. It is a transition. Understanding a paradox is a transition from confusion in understanding to understanding the confusion. So I thought that's a very nice way of explaining what's the paradox. So we'll start with that. What I will do first is tell what the paradoxes are. One by one, I will just state what they are. Then it will also give you some time to think it over. And then after I have written down all of them, these four, I will come to this at the end. This is not quite there's also one more which I wanted to write, I forgot. So let me call that 3A. Bell's question. I knew I had forgotten something. So these four, I will pose first. This I will come at the end after I finish. So let me start with the rocket paradox. I have two rockets whose breast length are the same. This is one, and there is another rocket which has the same length. Breast length in their frames. And this, if this is A, B is moving with a velocity V with respect to A, and A is of course having a velocity V in the opposite direction. So the rest lengths are L0 is the rest length. Now, let us look at the following situation in which the front end of A meets with the back end of B. That is, I have here the front end. This is the first one. Let me leave it. The front end, this is my A. meets with the back end. Here, A fires a rocket towards B, and at the same time, he fires a rocket from the back. From A's point of view, the length of B is contracted, its length is L0 by gamma, so the rocket will miss B. This is from A's point of view. But let me look at it from B's point of view. B's point of view, here is my rocket being fired. A's length is contracted by L0 by gamma, that's its length. In this case, this was L0 by gamma. So here, according to him, the rocket the bullet misses. According to B, the bullet is going to hit it right in the middle or somewhere there. Right? So which is correct? So that's the first practice. If both can't be right, only one must be the correct answer. Then let me go to the rocket and the plane. There, the situation is the following. I have here X, Y, Z as an axis, and here an aeroplane or a rocket whose length is L is traveling in that XY plane with a speed V. The way I have drawn it is along the y-axis. That doesn't matter. There is a geometric plane with a hole in it. Let me explain what is happening. Here is a rocket coming like this, and there is a geometric plane, a sheet of paper, say, or something like this, with a hole in it. This diameter of that hole is the same as the rest length of this rocket, and that hole is slowly coming from Z negative and it is going up. It will come to Z equal to 0 exactly when the middle of the rocket is at O. Okay? The whole thing is arranged in such a way that this plane is coming up and the plane exactly coincides with the XY Z equal to 0 when the rocket is at the middle of the hole. Now let's analyze it from the plane of the in which this is rising like this. The rocket will look short, so it will look like it will go through the hole. But let me look at it from the pilot's point of view. The pilot will see a contracted version, the diameter of it will be L0 by gamma. His own length is going to be L, so he is going to crash into the system. So which is correct? You can't have both. Either he will crash or he will not crash. Pardon?
It's not going to crash.
Please say
It will not crash.
why?
Because of that, he is observing that, but actual length is remain same.
No. That is not. What do you mean by actual length? It is a function of each observer. For him, the length will be L by gamma. And for him, the length is L. So as far as he is concerned, he is going to touch the plane. Either the front end or the back end or both ends are going to hit the plane. So you have to resolve that. The one frame is not superior to another frame. So I must be able to explain from either frames the answer. Okay? Then comes Shastry's paradox, and the paradox is the following. This is something which I would like to discuss at length, so let me draw the picture here and keep it. This incidentally is an American Journal of Physics, 55, 1981 or 87. I will check this. I have not written it properly. I will check this page. I will check this. Wrestling. This, let me explain. This is a bulb. There is a battery here. Right now, the circuit can be closed this way and the bulb will go. This rest length is also L0. Now, this one is moving with a velocity v. Let me also label this C and D. This is moving with a velocity v. So let us see it in two different frames. Let me see it in the frame in which this big frame is at rest and this is moved. That is, I will redraw that. So in that frame, what is going to happen? At some stage, this one is going to lose electrical contact. The back end is C, is going to lose electrical contact. But the front end still has not gone and touched the wire. It will take some time before it does. So there will be a certain time for which there will be no closed circuit. That means the bulb will not blow. Right? Let's now analyze this from the point of view of the frame in which this is L0 and that is L0 by gamma. Now, I am in the rest frame of this part. And I am having this frame move in this direction V. Right? This will be L0 by gamma. My length AB, this is AB. AB will be L0 by gamma, whereas this will be L0. So, this will leave this only after the front end CD. D will make electrical contact with the B portion before C will lose contact with A portion. So at no stage is there a loss of electrical connection. So this will imply the bulb will glow all the time.
Yeah.
So question is, either the bulb was glowing all the time, or according this man claims the bulb will not glow for some small, because the electrical connection is lost. So he will say this bulb will not glow, and he will say the bulb will glow. So you can't have both. The bulb either was glowing all the time, or it was switched off for a certain length of time. You can't have both.
It will glow.
Pardon?
It will glow because of the actual length will remain same. It is only observation.
No. What answer is it will grow. Then in that case, something must be wrong in the logic that I have used in this
first case.
What is the logic mistake?
That is what he is observing. L is equal to L naught root of 1 minus V square upon C square.
Right.
That is his observation, but actual length will remain same.
Now, what do you mean by actual length? That's the question.
See, physical value of that length, that h, it is always what same?
He is talking proper frame.
Proper fit.
No, but now, at any particular time, when I am looking at the front end and the back end at the same time, they are at a distance L0 by gamma. Whereas, at the same time, this is length is L0. So, this, when I touch here, D will be here. And when I move a little bit, both of them are in this without any electrical contact whatsoever. So therefore, according to that, the bulb should not go. So if you think the bulb should go all the time, something must be wrong with what I have said.
Length contraction.
Pardon me? There is length contraction. I have used the length contraction here.
See, in length contraction here, both bodies were in the same, they are lying in somewhere. And in length contraction was one body was moving up far from me, away from the actual observer. I think so this.
With respect to the other also, the length contraction for the gap is there.
No, I didn't quite understand. Please repeat your comment.
Even for the other one, if you take the other one as a
What is the other one?
Second case.
The second case here.
second case.
Yes.
So too there will be a length contraction for the other one.
No, I have had this length contraction. This is L0 by gamma and this is L0. So, notice, when C is in contact, D will also be in contact on the other side. So, as I keep moving, when C loses contact with A, D already is in contact with B. So, at no stage has the electrical contact been disturbed in this way. Is the statement clear? That is the Shastri's paragraph. I will answer all this. The next is Bell's question. Bell's question is this. There are two rockets at rest to start with, joined by a string of length L. By the way, this question is in his book on speakable and unspeakable in quantum mechanics. Though he talks about quantum mechanics, he does a little diversion and talks about relativity. So here is rocket A and rocket B. Both rockets are identical, they are just separated by a length L in my frame S. Both are identical, they are separated by this. This rocket is accelerated, both of them are starting at rest with some acceleration A, and that's also starting with acceleration. Both are identical, both start at the same time as far as my frame is concerned, and they will. Now, the length L will remain the same as the rocket is doing. The string is such that if it extended a little bit beyond L, then it will break. The question is whether the string will break or not break. Will it remain the same or not? It's the question. That is, if this length of the string was greater than L, it will break. If it is the same, if it remains the same, it will not break. So the question is, will the string break or not?
No.
Okay. I will answer this very soon. The Bell proceeds to say the following. After posing this problem, he was in CERN, where all these big scientists are there. So he went around asking a large fraction of them. And I forget the number of people who got the correct answer, maybe 5%, maybe 3%, some very, very small number of people who got the answer. And after they found the answer, then there have been a series of papers on why Bell is right and why there was a lot of argument to prove Bell wrong, because people were all upset that they had made the wrong answer. And those papers are all available in various places, especially if you look through the net.
Please repeat that problem.
I'll repeat the problem. Look, I have a rocket here. I have another identical rocket here. The separation is L. Both are at rest. I have a spring which I have attached. That spring is of length L, and if you try to increase the length of that spring, it will break. Now this rocket is started with an acceleration A. This rocket has also started with an acceleration A. They are moving. The separation will always be L for me, because whatever happens to this rocket as a time function, this is going to do it after this length separation of L, right? Whatever equation of motion I will write, if I write it with x equal to, I will write it with x minus L equal to. So the separation will always be L as far as that is concerned. They started at the same time as far as my frame S is concerned. Everything is being looked at from one individual frame. That's all.
Other frame, same
There is no other frame. I am only looking at one frame. Okay. Oh, there is, I keep adding, there is one more paradox I will talk about, that is Ernest. How do you write the spelling? Is that right? Or am I? Is that correct? Or do I mistake me somewhere? Who's? Ernest. Ernest. And I will not give you the answer to this because the answer to this is rather wrong. And one of the reasons I am mentioning this is it is related to Professor Mukunda's talk on Bayes space in its own way. Okay. So now, the last is the twin paradox, which I am sure all of you have heard, but I will repeat the way I would like to say. There are twins. There is A, he is at rest, and he goes, this is time, I am plotting his time trajectory. There is B, who goes with a velocity V, and according to his clock, he goes for a time T, V, that if T is the time registered in B's clock, A's clock will register T gamma. Because this is a clock which he will see, so A will have T gamma as the clock. So A will claim he is 2 T gamma years old. And he will claim B because according to B's clock, it's only 2T. So his time, biological development, all will be based upon his clock, will be is 2T years old. B, what will be B's claim? This is A's claim. B's claim will be, he says 2T years older, B. If this clock ran for a time T, what would be the clock that would be running for A? It will be T by now. So he will claim A is 2T by now. So there is some problem here. How do you resolve this problem? That is the next. So that's the twin paradox. So let me start with the first one before answer the. Would anyone like to give me the answer? Because that's one of the simpler ones. If somebody might like to answer that.
So A is also moving, sir? A is
No, A is moving with respect to B, B is moving with respect to A. That's all. There are two of them are coming like this, right? So if I am in A, B is moving towards me. If I am in B, A is moving towards me.
A is firing simultaneously.
A is firing, yes.
In his frame.
Good.
It may not be the simultaneous for me.
So how do you resolve this?
Take
Do events. Check events in the problem. Okay? So now let us say this frame is A's frame is x prime. because A's velocity is in that direction, I will make that as my x point. So here, when I am firing, let me call this x prime equal to 0, t prime equal to 0. Okay? Then, the firing which is taking place at the back is an event where x prime equal to minus L0 and t prime equal to 0. Okay? Simultaneous in A's frame. So, the first one firing took place, the event 1, the front firing took place at x prime equal to 0, t prime equal to 0. The back firing took place at x prime equal to minus L0, t prime equal to 0. So let us translate this into x. This, of course, x is 0 and t is 0. Let me write the Lorentz transformations and keep it for ourselves. It is x prime equal to gamma x minus t and t prime is equal to gamma t minus 0 x plus t. So what about the other one? Other one will be now, the inverse transformation is what I need. T will appear in gamma x prime plus v t prime by c, sorry, v t prime, t prime plus v x prime by c squared. T prime is 0, x prime is minus L, so I get minus gamma v L0. So what does this mean? From B's frame, the firing is taking place at time not 0 but earlier. So from this frame, he will see the bullet is fired, the bullet from the back is fired first, and then later on this is fired. So let me analyze this from B's frame. It is coming this way, and the B is firing it at an earlier time. So we should find out the x coordinate at the earlier time. So we can also calculate that. X is gamma x prime minus v plus v t prime, which is nothing but minus gamma L0. So the picture that we will see will not be this. The picture he will see will be that A is coming. When that distance is L0 gamma, his own length is L0, no problem. At L0 gamma, which is greater than L0, the bullet will be fired at an earlier time. Then he will come here and then fire the next bullet. So the bullet from the back will not hit him. In both frames, this statement is valid. And if the argument, the way I presented it, was loose thinking, because what is simultaneous in frame A is not simultaneous in the other frame. And if I analyze it using events, I have no difficulty. Everything works completely. Is this okay? So the message is to, whenever there is confusion, talk in terms of events and see how does one event translate into another event in that, and then things get us. Now let's go to this problem. This problem, I have this rocket which is moving like this. Let us write down the equation of this plane. This plane is z equal to ut. If u is the velocity of this plane. What did I say? This geometric plane is slowly going up. So it is going up along the z direction. At t equal to 0, z is 0. This is the equation. Let me see how does this look in the rocket frame. But t is nothing but u times gamma t prime. The rocket frame is moving in that direction. I have put along y, so I write it as t prime v y y. yt, this is t, what should I write? T prime, y prime. So if in the rocket frame, I have y this way and t prime this way. So what does this equation look like? This one is constant. Right? Z is equal to Z prime. So Z prime equal to this plane looks like that. Right? If I put this equal to 0, I would get, okay, that is, or am I saying it rightly? Z prime, U, T prime, Y prime, and what will be this plane now? Equation of this is Z prime. Okay, Z prime. Let T, and now I did it. Put T prime equal to 0. This equation is Z prime equal to U comma V Y prime C squared, which is nothing but this. So what does this mean? It means this plane, which was moving up like this, when I see it from here, I see it tilted like this. So the board is tilted and my aeroplane just goes through. Because the board is tilted, the aeroplane goes through. Whereas in the other frame, the aeroplane looks shorter and the hole looks bigger and it goes through. So the plane does go through in both frames. Is this argument clear? So there is no paradox if you use appropriate transformations.
The major difference between normal working out the calculations and doing it in special period relativity is normal difference we use only coordinates and time as parameter.
Exactly.
Here actually the time is a variable other than a parameter. So when we are thinking of length in different frames, we have to consider the corresponding time or what you say event in those frames.
Now, I will like to spend some considerable amount of time working this out because there is a message in this one. The answer is, contrary to what you said, the bulb will be switched off for some time. Both frames. You will see why. The analysis is a little messy, but still I would like to show it to you people and you can. And those of you who are interested, I have the notes, they are welcome to take it. Anyway, you can read it in Professor Shastri's paper. It's a very well written paper, he has explained all the steps. Okay. Let's firstly analyze, according to this frame, yes.
So the tilting part, I got it.
Did you get the tilting part?
The tilting part, I got it. But how does that guarantee the passengers will rocket?
Now, no. Once the tilting part happens, what did I say? I said that at z equal to 0, the middle of the plane is here. When the middle of the plane is here, the aeroplane is only in the z equal to 0 plane. So when it is coming like this, so the front tip will always enter, it will continue to go. You can of course, at this point, the thing is tilted like this. What you are asking is, when it goes, yeah, you can check that. That part. Yes.
In fact, even the first part, the plane is
Yes.
tilted.
What you are saying is, when I have come here, it's still in the hole. That's right. One can check that. I only checked it for the middle point. But once you have realized the thing tilts, the answer is that it will pass through based on that.
No, it is. See, as the plane is tilted, it is quite possible that before it comes up.
That's possible, but one can. I have already made the center to coincide. Yes.
Is there any concern about the velocity at which the plane will
No.
get up?
No. Nothing. See, right now we are thinking of a geometrical thing.
You are having
So,
one velocity like this.
and another velocity like this.
But
This can be
this-
very slow.
Very slow.
The speed of that is irrelevant. It will just need to tilt a little bit for the plane to move.
This is just a naive question. That whole whole became like this. Why did the earlier rocket didn't turn out to be?
No, by the way, for me, notice, in the frame S, this is moving up, and that rocket is coming like that. Is it clear? Okay. Now, let me spend some time. So let's write down a few equations. To do that, I want to use certain notation, and let me write that down. I will consider two events. Event L is when C loses electrical contact with D. Event R, D contacts with B. Okay. Let's call different frames. This frame I have called S, and I have called this frame S dash. Okay? In S, I have this thing is moving. In S dash, I have the other frame. In S, notice, in S, TL will occur and TR will occur later. Why? Because firstly, there will be a loss of electrical contact. C will come here. D will be at a distance L0 by gamma, whereas that is L0. It will have to travel some time and then it will again get in touch. So, let's write it down in S. I will write down T L T R minus T L will be L0 minus L0 by gamma divided by, right, which is L0 Now comes the most important physical thing which you should realize. When D touches B, during this much time, certainly the light there is no electrical contact, so there is no question of any current flowing. Moment D touches B, the current will not start. If the current has to start, that would mean the charge carriers will have to move with infinite speed from here to there. Nothing in relativity can move faster than light. So, I need to take a certain amount of time for charge carriers to move this extra length. This length I am making it small, it is just exaggerated to show the picture. It has to travel this length L0. Okay. So, the time off in frame T off in frame is L0 1 minus 1 by gamma V plus L0 by Vs, which is the speed of the charge carrier. Now, let's go to S prime. Firstly, let's calculate P prime R minus P prime L. So, in this prime, notice this number what I am going to write down is going to be negative. Why? because T prime R is going to occur before T prime L. What is T prime R? T prime R is when D makes contact with B. That's what I've written down. D makes contact with B would be T prime R. So when D is in B, this length will be L0 and that will be L0 by gamma. So T prime by R would be L0 with a minus sign, 1 minus 1 by gamma divided by. Please notice that T prime R is the time in which D would make contact with B, and T prime L is when A would make contact with. Something very interesting which today morning we saw. What does this mean? In one frame, TR is greater than TL. In another frame, TR prime is less than T prime L. What does this talk about the two events R and N? What can I say about it? They are space line. The separation between these two are space line. Okay? Only then can this happen. Now, let us calculate T prime of that will be equal to minus L0 times 1 minus 1 by gamma by B plus, now in this frame, the velocity of the charge carriers was Vs in this frame. In this frame, it will be Vs prime, because in this frame, this thing is at rest and the entire frame is moving with the velocity v. So I will have Vs will be the, now I will calculate the time, Vs prime will be the velocity of the charge carrier. What should the charge carrier do? This thing is moving this way and the charge carrier has to catch up with A. To catch up with A, suppose the time required is T prime.